So this is the properties of matter, unit 1.4, and we should be focusing on how physical and chemical properties of matter determine the composition of the material. So when we focus on different elements, we compare them using various quantities, properties of the material. The mass, volume, and calories are extensive, and hardness, density, and boiling point are intensive. But they will relate to the various properties that each element incurs. So physical properties are focused on things that are visible. They can be measured, and they will be relatively the same regardless of the amount of the material. Chemical properties are only observed when changed by changing the composition, whether it's combustible, decompose, or fermenting that material. So chemical properties require outside elements to determine. Some specifics: is it flammable, like oxygen? Is it reactive, like sodium? Is there a color change in the production of gas, formation of precipitate? That is an indicator of a chemical change. You can always see the chemical change. It's taking place based on what's happening. Physical properties are obviously observable, but when you move with the material, you can also tell some of these physical properties. Metals are highly conductive. They transmit heat and energy. They're also malleable. They can change and move without breaking. They're not brittle. Color is representative, but obvious as well. And reflectivity, whether it can absorb or radiate light. So when we're thinking about specific elements, we're focused on compounds or specifically elements that are found in the periodic table. And this is, a single thing, for lack of a better term, because it's difficult in nature to find most elements by themselves. So it's difficult. Sometimes it's hard to extract the specific element. And some other terms to use to describe these are viscosity, hardness. The hardest known element is diamond, which is made of carbon, and it's been exposed to lots of heat and pressure, different from a lot of natural forming carbon. So the Tyndall effect, scattering of light through a particle, and the amount of scattering depends on the frequency and density of the particles. So the size has an impact on scattering of light. And because light is a wavelength, each element is going to emit a different light based on the wavelength of that element, which kind of is indicative of the electrons that are on that specific element. So mixture, if I blend two substances together, if I have a heterogeneous mixture like salt and pepper, I could separate the salt and pepper granules. So I could distribute that material if possible. But if it's homogeneous, it's going to be very difficult. Once I dissolve salt in water, I can get the salt and the water separated, but it's going to be a lot more difficult. This is typically known as a solution, where heterogeneous is usually a mixture. Here's some looking at the particle distribution for heterogeneous versus homogeneous. And some more examples are provided as well. So when you're describing the solute, you're talking about just the small amount, the material. If you think of lute as in gold, it's the smaller amount. In our saltwater example, it would be the salt. The dissolving agent is typically water, but it can be other solvents that are used in various quantities. But usually it's the agent with the most quantity in the solution, which is a liquid mixture of the two. Soluble means that the object is able to be dissolved, like salt in water. Salt can be dissolved. Insoluble would be unable to be dissolved. If I tried to dissolve diamonds in water, it wouldn't work. It would be insoluble. Concentration is relative to the particular substance. If I say that a substance is saturated, it means that you cannot add any more solute. If I put as much salt in water as will be absorbed, there would be a remaining amount of salt at the bottom of the container, and it will not dissolve in water anymore. Unsaturated would mean you could dissolve more in that substance. Supersaturated is you're using some sort of diffusion assistance like heat to increase the concentration beyond the normal saturation point. If I were to make a solution dilute, I would add water, and it would create a dilute mixture. And these are all really important, especially in chemistry, when we're talking about making specific concentrations. So be familiar with the terms here. These are some solubility curves, and all dissolve in 100 grams of water at the various temperatures. Some objects can dissolve more of that compound in higher temperatures. You can see that salt is kind of relatively unchanged, but you can dissolve more as the temperature increases. And a lot of these are just various salts. So here are the three types of particles, and we'll go into detail when we talk about the periodic table. So that's the notes for today. Please feel free to reach out if you have any questions.